Hello and welcome. Today, we're going on an incredible adventure. We're going to follow a single, tiny piece of data as it travels across the crazy, complex world of the internet. We are going to pull back the curtain and see the magic that happens every single time you click a button, send a message, or stream a show.
I mean, think about it. It feels instant, right? You hit send and poof, it just appears on the other side of the planet. But how does it actually know where to go? Out of millions of possible roads and highways, how does it navigate that maze to find its one true destination?
Well, let's meet the hero of our story. One single data packet. Its mission, should it choose to accept it, is to travel from this computer, PC1, all the way across this network to its destination, PC4. This diagram here, this is our map, and we are going to follow our packet every step of the way.
All right, our packet is all bundled up and ready to go. It knows its final destination address, but it immediately has a problem. How does it even get out of its own neighborhood?
To get this, let's use an analogy I love, the Postal Service. The IP address is like the final street address you write on a letter. It tells you the ultimate destination, 123 Main Street, Anytown, USA. And that address never, ever changes during the trip. The MAC address, though, that's different. That's like the local instruction for the mail carrier. It's the address for the very next stop, like, take this bag to the main sorting facility downtown. And that instruction is going to change at every single point in the journey.
So PC1 knows it can't deliver this packet to a whole other network all by itself. It's got to hand it off to a specialist, a device that knows how to talk to the bigger, wider world. And that specialist is the router, specifically the default gateway, which for us is router R1.
But wait, there's a problem. PC1 knows the IP address of its gateway, but to actually send the packet locally to hand it off, it needs that local delivery address, the MAC address. This is where a super important protocol comes into play, ARP, the Address Resolution Protocol. You can think of ARP as the network's way of asking a simple question. Hey, I've got this IP address. Can somebody please tell me what your local hardware address is?
So PC1 sends out an ARP request. And think of this like shouting in a crowded room. It sends a broadcast message to every single device on its local network. It's basically yelling, excuse me, who here is 192.168.1.254? I really need your MAC address.
Now, every device on the network hears that shout, but only one of them recognizes the IP address as its own, router R1. And it doesn't shout back to the whole room. No, that would be chaos. Instead, it sends a direct, unicast message right back to PC1, kind of like a whisper, saying, hey, that's me. Here's my MAC address. It's AAAAA.
Okay, now this is where the real magic happens. Let's look at how the packet is actually packaged up. The inner IP header, that's our letter. It contains the original source and the final destination. That part is sealed and never changes. But the outer MAC header, that's the envelope, is addressed only to the very next stop, router R1. And just like that, our packet has made its first hop. It successfully left home and arrived at the first guidepost on its journey, router R1. Now, the real navigation is about to begin.
So, our packet is now sitting at router R1. The router accepts the packet, opens up that MAC envelope, and sees the letter inside isn't for it. R1's job is to figure out where to send it next. So how does it know?
It checks its own internal map, which is called a routing table. The router looks at the packet's final destination IP and asks its table, hey, what's the best path to get there? The table's instructions are crystal clear. To get to the 192.168.4.0 network, you need to send a packet to the device at 192.168.12.2. And who's that? Well, that's router R2.
And this, right here, perfectly shows the core idea. R1 strips off the old MAC envelope it got from PC1, the IP letter inside completely untouched. Then R1 puts that same letter into a brand new envelope, addressing it from its own MAC address to the MAC address of the next hop, which is router R2. The journey continues.
So our packet is now deep in the network, hopping from router to router. And what seemed like a whole bunch of steps is now just becoming a clear, repeatable pattern.
The packet arrives at router R2. And what does R2 do? You guessed it. It does the exact same thing R1 did. It strips off the envelope, looks at the destination IP address on the letter, and consults its own local map.
Now, R2's routing table has its own unique set of directions from its point of view. It says, to get to the 192.168.4.0 network, The best next stop is 192.168.24.4, and this is the IP address for router R4. With those instructions, R2 knows exactly what to do next.
So here's that crucial repeating cycle again. R2 builds a third, brand new MAC envelope. Now look again, the IP source and destination have been exactly the same since the very beginning, but the MAC addresses, the envelope, are brand new just for this specific hop from R2 to R4.
Our little packet has traveled across multiple networks. It's been handled by different guides, but its goal has always stayed the same. And now, it is just one step away from its final destination.
The packet arrives at router R4. This moment is different. It's special. R4 is the gateway router for PC4's own local network. It is the last guide our packet is going to need. The end of the line is finally in sight. R4 does the same check. It looks at the destination IP 192.168.4.1 and checks its routing table. But look what it finds. Directly connected. This is the magic phrase. R4 knows the destination isn't somewhere else out on the internet, it's right here, in its own backyard.
Because the destination is local, R4's job changes from being a long-distance guide to a local delivery person. And to make that final delivery, it needs the specific MAC address of PC4. So what does it do? It performs one last ARP, broadcasting onto its local network, hey, who has the IP address 192.168.4.1?
PC4 replies with its MAC address, and for the very last time, the packet is placed in a new envelope. And this time, the destination MAC address is finally the true destination, PC4. The packet is delivered, its incredible journey is complete. So, what did we learn from following our little packet? What is the secret that allows this unbelievably complex system to work so perfectly billions of times every single second? Well, it all comes down to a few key principles. IP addresses are for the global, long-distance final destination. MAC addresses are just for the local, hop-by-hop address to the very next device in line. Routers act as the intelligent guides, unwrapping and rewrapping the packet at every single step to send it along the best path. We've just followed the life of one packet, but the real internet is a constant storm of millions and millions of packets, all following these same rules all at the same time. That incredible coordinated dance is what makes our entire digital world possible. If you enjoyed this journey and want to see more explainers just like it, clicking that subscribe and like button really does help us out a ton and lets us keep making more. Thanks for watching.